Alright, now I want to make sure that we get more practice with the theorems that we covered in 7.2. So I don't usually do this, but I'm going to cover a large portion of the extra practice. The first three problems are up to you to do, but I'll help you with this large portion here so that we can get some good extra practice with those parallelogram theorems so that you guys can do your homework. So there are four theorems that we know. Now make sure that you have that other page of theorems, but we know one, that opposite sides are congruent. Okay, opposite angles are congruent. 3, we know that consecutive angles are supplementary, so they add to 180. And 4, we know that diagonals bisect. Okay, and so what we're trying to do here is we're trying to find all the measures of these indicated side lengths and angles. Now the problem with this diagram, which is probably a flaw from the publishers of the book, they didn't include this, but they didn't include it in the instructions. Maybe this right here means parallelogram, but it's kind of hard to tell. But let's assume that it is saying that it's parallelogram because there's no other indication of whether or not these lines are parallel. So we will say that they are parallel, and I guess we'll assume that this figure right here is indicating that it is a parallelogram. Okay, so if they are a parallelogram, so if this is a parallelogram, then we can use these theorems. So first we're trying to find the length of PO. So this length right here. Now we know that this side length is congruent with this side length because opposite sides. So that means this is equivalent to 24, and that's from the opposite sides parallelogram theorem. Now I'm going to be pretty lazy. Opposite sides, the official name is parallelogram opposite sides theorem, which says that opposite sides are congruent. Okay, and then OQ, we want to find OQ for the next one. So OQ is this one right here. Now OQ is congruent to MQ, and I know this because Q is the midpoint. Q is the midpoint of both of these line segments, and I know that from number 4, and that's because the diagonals of a parallelogram bisect. So that means this is the midpoint, and if this is the midpoint, these two segments are congruent. So I know that OQ has to be equal to 14. So this is from diagonals theorem. Parallelogram diagonals theorem. Alright, now NO, so this side length there, well, I know that it is parallel with this one, and it is congruent, so it's equal to 26, and that's from opposite sides theorem. PQ, so from here, nope, not that one. So from here to here, PQ, and again, Q is a midpoint, so that means that this and this segments are congruent because it's Q is the midpoint. So PQ is equal to 20.7. Again, that's from diagonals theorem. Alright, now PMN, so here's P to M to N. Now we're talking about the angles. So this angle right here. Now what we know, if from a parallelogram from the third is that consecutive angles are supplementary. So I know that this angle right here and this angle right here add to be 180. Now this arrow is pointing to this angle right here, not just this angle. So I know that this one is 68, and so since I know that these are consecutive angles right here, so I know that if I do 180 minus 68, I can find the other side, which should be 112. So I know that this is 112. So angle PMN is equal to 112 degrees, and that's from consecutive angles theorem. Okay, so this is 112. Alright, now angle NOP. So NOP, now we only have one side of this measure right here. So this is 59. We don't know what this is right here. But we do know is that this side right here is congruent with this side right here, or it's or that it's congruent with or it's supplementary with its consecutive angle. So let's knowing that we know both of these angles now, so here's 112. Let's just use the consecutive angles theorem. So I know that this angle is 59 plus x, and then if I add this angle right here, so plus 68, I know that the sum of these angles will be equal to 180 degrees. So I can subtract 68 from both sides. I could also subtract 59 from both sides. So here I'm just left with the x. So I know that x is equivalent to let's see, so 180 minus 68, and then minus 59, and I get 53. So this right here is 53 degrees. Now I want to find the total sum of this measure right here, and that means the total sum of this measure, so 59 plus 53 is 112. Now again, we already knew that because we also know that these are congruent angles. I just wanted to make sure that we understand both of them, okay? So you can use either theorem. So the easiest one though would just to say that opposite angles are congruent. So I know that NOP is equal to 112, and that's from opposite angles. Or you could say from consecutive angles are supplementary. So here I know I got 112. This was 53. The total was 112. I know that this is 68. Okay, now we want to find angle OPM. So here's O to P to M. So O to P to M, that's just going to be 68 because opposite angles are congruent. So by opposite angles. And last but not least, we want to find angle NMO. So NMO. Now first of all, we found that this was 53, right? So NMO. Well, I guess that's irrelevant, sorry. But we do know that this angle right here and this angle are alternate interior angles, and that means they are congruent, so this has to be equal to 59 degrees. And that's from the alternate interior angles theorem. Okay. Alright, so hopefully that gives us enough practice with all these theorems. Again, you'll be using these theorems in these three examples up here to solve for x and to solve for y. So it's up to you guys to do that on your own. And if you have questions, just email me.